So what you guys don't know is this is take number 3. I have biffed up on saying a couple things wrong, and so this is take 3. Hopefully this is the final cut because I gotta get out of here. I gotta get ready for my game. So anyways, we are still working on factoring. We have learned factoring by GCMF, where that's where you just pull out the common factor each term. We have learned how to factor ax squared plus bx plus c and x squared plus bx plus c, where the way that we learned to do that is by that ninja star. And today you're still going to be factoring. That's why I call it the F word, but we're going to be factoring what we call special cases today. So that's what we're working on. Now, some of these patterns you guys have already seen the names of. There's 2 different patterns. You've also seen special cases, but in the beginning of the chapter, you saw it as multiplying special cases. So remember, I said we're going from the problem to the answer, and the last half of the chapter, we're going from answer back down to problem. That's what we're doing now. So here we go. First pattern is difference of squares, which is the same name when you are multiplying. So difference of squares. I'm looking at the examples. So if we have a squared minus b squared, that's what your answer is going to be. It's going to equal when you factor it, not equal that you're solving, but equal when you factor it. It's going to be a plus b times the quantity a minus b. And it doesn't matter if it's plus minus or minus plus. That part doesn't matter. It doesn't matter where your signs are, as long as you have one of each. And it's still called the difference of squares when you're multiplying out the 2 binomials. Same name whether you multiply or factor. And so your other one is called a perfect square trinomial. My cues aren't looking good. Which I know I've mentioned it in class, but I don't think I've necessarily written it down. But a perfect square trinomial, hopefully you guys recognize this. Because I know a couple of you guys were like, wait a minute, where is that coming from? So I have a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So perfect square trinomial. So actually I was going to talk about this 2ab part, but I'm going to hold off on that for a second. And so when you factor these, you get quantity a plus b squared for when it's plus 2ab, because we talked about sign patterns when your last term, which was c, when c is positive and b is positive, that means your factors are positive. Or if you have minus 2ab, when you factor that, you're going to get a minus b squared. But remember, you got to say this with the quantity. So you're going to say the quantity a minus b, pause, and then have your square at the end. Now these guys, these are called square of a binomial. So when you multiply these out, I gave you the name square of a binomial. The answer was called a perfect square trinomial. And I don't remember if I actually wrote that down or did not, but now you have the terms. Okay. Also, please do not do that green poster on the wall with this guy. Remember, you're squaring the quantity, so you have a plus b and a plus b. Over here, you have a minus b and another a minus b. So these are the patterns we're going to be working on. We're still factoring, but you're going to see the 2 different types. You're going to be using Ninja Star, and then also a different way, because Ninja Star doesn't work super great with this one. We've tried it a couple different times, and there's some problems definitely that's it's not so fun to do. So here we go. I'm going to erase this so I have full board. So example 1, here we go. Factor are your directions. So we're going to go x squared minus 25. We're going to factor that. So since this is a difference of squares, and also from here on out, you're going to start to hear me say, how do you identify a difference of squares? It's always 2 terms. The first term is always quadratic, meaning it's squared. And the second term is always a constant, and it's being subtracted. Because sometimes it can get confusing if this is a difference of squares or if you factor it by GCMF. And so being able to start to recognize this is going to help you when at the end of the day, when you've got all these problems mixed up, how do I factor it? So start recognizing it as difference of squares, meaning first term is quadratic, it's subtracting, and a constant. And this has to be a perfect square. So here we go. Now the way that I factor these, first I set up two binomials. I put a plus and a minus. It doesn't really matter which one goes first, which one goes second. And when I do this, to get your first and your last terms, I'm going to take the square root of the first term. So the square root of x squared is x and x. And then the square root of 25, which is 5 and 5. And you got it. And also to double check it, you can always multiply this out. Multiply this back out. So it's done a little bit differently. I don't ninja star this one. I just take the square root of each term and square root of first and last term, which is your quadratic and your constant term. And here comes another one. So when problems are written backwards, keep it in that form. It's just easier to do it that way. And I know it's kind of, wait a minute, what am I doing? Frustrating because you don't know when to rewrite it in standard form versus not. But here's my rule of thumb. If it's written not in correct order, keep it that way when it's problems that you're factoring and or multiplying. But adding and subtracting, you got to put that guy in standard form. You got to. Okay, same thing. Set up your two binomials and plus minus, or you can do minus plus. It does not matter. And then square root the first term. So square root of 64 is 8 and 8. Square root the last term, which is y and y. And you just factored it. And if you always want to check, multiply it out and prove it. Okay, let's do some more. 4z squared minus 1. So difference of squares always have two terms, quadratic term and a constant term, nothing else. Because remember, if you multiply these out, just let's say you're like, oh, I don't quite know if I got that right or not. Multiply it back out, and what happens is your oi, meaning your outer and your inner terms, those are opposites, and they end up getting a 0. That's why you don't have your linear term. So here we go. You're going to do the same exact thing as you did with these other two. The only thing different about this is there's now a coefficient that's greater than 1. So, binomials, plus minus, minus plus. I'm going to go minus plus this time. You are still going to take the square root of the first term. But on this one, you got to be careful because you have a coefficient. So it's the square root of 4, which is 2 and 2, and the square root of z squared, which is z and z. So when you take the square root of a variable that's squared, you're thinking a variable times a variable to get the variable squared. And then same thing over here. Take the square root of the last term. Square root of 1, which is 1 and 1. There you go. Hardest part on this, or the part, I don't necessarily want to say hardest part, but the part that kids get stuck on is they forget to take the square root of the coefficient. Let's do one more. Let's go. I can't ask you guys for numbers here. 16a squared minus, I'm going to go look at some squares over there, 196. I double check. Okay, same thing. Set up your two binomials. Plus, minus, minus, plus, doesn't matter. Square root the first term. So remember, it's the square root of 16, 4 and 4, and the square root of a squared, which is a and a. And then square root the last term, 196, which is 14 and 14. There you go. Okay, so that's the first part. That is factor pattern number 1. That would be your factor pattern of difference of squares. Okay. Remember, the only thing different about them is their signs. You always have the same first and last term, and the only thing different about the binomial is you have a positive and a negative, or you can have a negative and a positive. So there goes that. On to example 2, because I have 2 examples, 3 more. Oh my gosh. I have 3 examples to get through, 2 more to do. So example 2 is still factor. Surprise, surprise. Okay. Let me scroll down and get some problems. So this is where we are going to be factoring our perfect square trinomials. So you have, let's go n squared plus 8n plus 16. we're back to a ninja star. So we're going to ninja star this guy. So when you have a special case, when you have a perfect square trinomial, your constant term has to be a perfect square. That's the whole point of having a special case. So if your constant term is a perfect square, that means your factors are going to be the same. Let's prove it. Okay, so a times c at the top. Remember, a is the number in front of your quadratic term. So it's 1 times 16, 16 here. b at the bottom, which is 8. ax and ax, so it's going to be n and n. Okay, and let's just double check our signs. Since c is positive and b is positive, that means both factors are both going to, oh my gosh, it's one of those days. Both factors are going to be positive. So factors of 16 that add up to 8, and it has to be the same factor. So it's 4 and 4. Plus 4 plus 4. Always double check to see if you can simplify, and you cannot. So you can do this. That's not the best answer you can get. The best answer you can have is writing it as a square of a binomial. Because you're going to have that in all your problems when you factor a perfect square trinomial. It is going to be the square of a binomial. So it's kind of nice today because all the problems, okay, it's a perfect square, so that means your factors have to be the same. So they're either going to be both be positive or both be negative, which means C is always going to be positive when it's a perfect square. B can either be positive or negative. Both factors have to be the same sign. So here's another one. X squared minus, what number are we going to do? I'm going to stick with the 16s. Minus 16x plus 64. Okay. Do you still have to show this work even if you can do it in your head? Yes. Okay, here we go, ninja star. C is positive, B is negative, so that tells you your factors are negative. Okay, A times C, which is 64. B at the bottom, negative 16. AX and AX. In these two problems, A is just 1. You can put your ones if you want, but you're not going to see it. All right, so basically what's if 64 is a perfect square, the square root of 64 is 8. And to double check, excuse me, negative 8 plus negative 8 is negative 16. Always double, triple check to make sure you can't simplify those. And since you cannot, you're done. Always write your answer as a square of a binomial. That's the most algebraic. This is what you're going to see over that. So let's say you're taking, I don't know, like a multiple choice test or something like that. And you have this on your paper. I hope you can recognize that these two are the same. Good. That's like an A. This is an A+. So this is the answer we want. Let's go for, they don't give me many problems. Okay. Let's see if I can create. I hope it comes out. I'm creating at the bottom here. Okay. Let me just double check. Yep. 4x squared minus 12x plus 9. They gave me like 2 examples in the book, guys. So there's not much in here. So, all right, here we go. Same thing, you're going to ninja star this. Okay? So ninja star, ninja star. Okay? A times C, so it's 4 times 9 at the top, 36. B at the bottom, negative 12. So sign patterns, you can do this anytime you want in the problem. C is positive, B is negative, so that means factors are both negative. Because remember, these are all perfect squares. And you can't have a perfect square if you multiply a positive times a negative. It doesn't work that way. AX at the top, so now we have 4x and 4x. Okay, factors of 36 that add up to negative 12, they're the same. Negative 6 and negative 6. And just like yesterday, check to see if you can simplify these. So you're looking at reducing it. So what goes into 4 and 6 equally? That's 2. So it goes in here twice and down here 3 times. And since we're going to have the same binomial over here, I don't know if you guys have caught on to that, it's 2 and 3 again. So then you have 2x minus 3, but I have another one, so we are going to keep that as the square of a binomial. So Ninja Star, this is a lot like, this is what we've been doing for the last 2 days, but now they're just special cases because they're perfect squares, which means you're going to end up having the square of a binomial when you're done. Okay, one more example. I'm already at 15 minutes, not too bad. Last one. They don't really cover this much in the book at all. However, it is in homework. These are what I call hidden. You can call them special cases or perfect squares or whatever. Hidden cases. Let's call it that. I don't know. I don't have a great name for it. So hidden cases. So what these are polynomials that are perfect squares or difference of squares, but they're hidden within the polynomial because they don't initially look like that. For example, I get some problems here. Where's the other page? Here we go. Y cubed minus 9y. Now, if I hadn't told you this is a perfect square or a difference of squares in here, this I would go, okay, I'm going to factor by GCMF. However, it ends up being that and more. This is when they're hidden cases. These are what I call a double factor problem. You're going to factor it twice because hidden within it is that difference of squares or perfect square trinomial. And the first way that you're going to factor it is by GCMF. That's why they're hidden. They're sneaky. They're just... And yet another reason why we call it the F word, because you have to factor twice for every problem. Here we go. So first is always by factor by GCMF. Always factor GCMF. Okay? That's always the first thing you're going to do. So what can you pull out of both terms? That's a y. Now tell me what's left. So y times what right here gets me y cubed, which is y squared. Y times what gets me negative 9y? That's a negative 9. Now, at this point, you should have either a difference of squares or a perfect square trinomial. If you don't, then you did something wrong when you factor by GCMF first. So that's the first step. The second step, you're going to factor by, how are we going to factor that guy? Square roots or Ninja Star. So it just depends on what it is. If this is a difference of squares, then you're going to factor it by square roots, like example 1. Or if it's a perfect square trinomial, then you're going to factor by the Ninja Star. Here we go. So this is going to be square roots. We can't forget this guy right here, though. So I'm going to bring this guy down. And I'm going to factor this guy the exact same way I did in example 1. I'm going to set up, I don't know why I wrote that all the way down there. Do binomials, plus minus, minus plus, doesn't matter. And then square root this guy, square root that guy. Looks like I kind of erased that. So square root of y squared is y and y. Square root of 9 is 3 and 3. And you just factored. These are leading into extension 7.9, which is a double factor problem. It's called factor completely or factor by grouping, and I'm going to be here to do that with you guys tomorrow. But these are still hidden special cases, so that's why we do them today. But it's kind of nice because now you get a heads up of what's happening. Okay, so these are going to be the steps for any of these problems that follow example 3. So it's always GCMF first, and then it's either square roots or Ninja Star. All right, I'm going to do another one. I'm going to keep those right there, though. And let's go. Gosh, they just don't give me many problems, guys. Okay. 9m squared plus 36m plus 36. Now, it looks like you would just automatically Ninja Star. However, since I am telling you it's a hidden special case, which means there's a hidden perfect square trinomial or difference of squares, that means you're going to double factor this. So here we go. 1 factored by GCMF. So what can you pull out of each term? Remember, you want the greatest. So if you don't pull out the greatest, you can still get the same answer, but it just might take a little bit of work to get there. So here we go. I'm going to pull out a 9. And now let's tell me what's left. So 9 times what? Right here gets me m squared. 9m squared, sorry. M squared. 9 times what right here gets me plus 36m. That's plus 4m. 9 times what gets me 36? Plus 4. That's the first time. Now, on to step 2. Square roots? No, I'm not going to square root that because it's perfect square trinomial, which means you're going to have to ninja star. So at this point, I just do the ninja star underneath. A times C, 4, B at the bottom. AX and AX. And since it's a perfect square trinomial, you know the factors have to be the same with the same sign. And since B is positive, it's going to be a plus 2 and a plus 2. And so you have the quantity m plus 2 squared. And this is where the most common mistake is made. Kids will forget to bring this guy down. You've got to include that original GCMF factor, which is 9. So if you just end up putting this, the quantity of m plus 2 squared, that's only going to get you m squared plus 4m plus 4, which is not the original problem. So you have to make sure you include your GCMF factor. Okay, so you could put it right here if you want, or just put it, your GCMF with an arrow down. That's generally what I do, but you're going to find out what works best for you. Okay, so there you go. So it's practice of 7 point whatever lesson that was, and it's practice of today's. So double factor problems. I'm only going to do one of those because this is already like 20 minutes and I want you guys to get started in class. And you only have, I believe, like 2 or 3 of these problems to do. It's not many of them. Yeah, there's 4 of them. 4 problems. And remember, if you have like m to the 5th, m to the 4th, m to the 3rd, remember you take out the lowest amount of m's because they all shared m3, m to the 3rd, pardon me. You're going to pull out that m3. I just thought of that in case you have problems where you have to pull out also not only a coefficient GCMF, but then also a variable. So there you go. Have a good day. We're off to our last part of factoring tomorrow, which is factor completely and factor by grouping. Grouping is when you have 4 terms. When you see factor completely, that generally means double factor problems. The reason why we call it the F word. Bye.